Hello and welcome to this TRINITY video. This video demonstrates how the module Additive Welding, WAM or Wire Arc Additive Manufacturing can be used and operated. In this video we will present how to start the system, how to enable the additive function that allows you to use the 3D printing function with the simulation software. And we'll also explain how this system works. So the first thing you do is open Visual Components and then load your digital twin of your welding system. You can also add a welding plate where you are actually going to be doing the physical welding. And then to activate the welding function, you first press on the modeling, which is in the top corner, and then you scroll down to the welding file, which is inside behavior. In the welding file, you can then scroll down and you will see some parameters where you can turn off and turn on the welding function. Here you can also choose number of welds. This means how many layers you want to put on. In this case it says 8. And you can also choose the distance between each weld. In this case it is 2 millimeters. And then you use weld 3D print. If it's 1, then you have enabled the 3D printing function. If it is 0, then it is disabled. In this case, we're going to turn on the welding, have 2 millimeter increments between each weld and 8 layers. Afterwards, you can close out of this window. After 3D printing has been enabled, you can then move over to Program, which is then again used for programming of the system, similar to the last module, Simulation Welding. As you can see, there are a few sub-programs in the tab. In this case, for doing the 3D printing, we're using the 3D Print sub-program. This is the place you add the position and create the program. For the first part, we're going to weld a straight line. Therefore, first we're moving the robot head down to the plate and making it touch the plate. Afterwards, we move it up to set the starting position, and then we can drag it up so that it starts in the end and then afterwards goes down to the point. And then we will move it to the side. And at the end, we will move it a little bit up with a linear movement before stopping the program. And then we again use the set output to turn on the welding torch. And in this case, the welding torch is turned on while it is moving to the side, so welding a line. In this case, it is also recommended to reduce the speed of the robot arm. In default, it goes in 100% speed, which is too fast. Afterwards, when we actually run the simulation, the visual components and the program we have will automatically generate a full printing routine in the subprogram printing routine. Here you will have 8 layers of 3D printing with 2 millimeters increment between each weld. And this is all generated automatically with the same position. This is used to create a thin structure wall. And here you can see the robot running the program, and it's all going up a little bit for each time. And we can also move around in the simulation to verify that everything is okay. And it is in the printing routine you have the whole program. We can also go into the welding file again by going to modeling and welding. And we can then again change the parameters to turn off and on the welding. We are now going to test and try to instead do 4 welds and then also increase the increments between each weld. So 4 millimeters increase, and we're going to do 4 passes of welds. Before we run this simulation, we do first need to delete the previous program, which is in the printing routine, and then we can again weld. And here you can see a different program running with different increments and different number of layers. I will also showcase a second example of using the 3D printing. In this case, the 3D printing is enabled. First, we program it, but in this case, we are also directly connected to the physical robot. So after we have programmed the system, we then transfer the program over to the physical robot, as you can see here, and then we are running multiple lines of weld and building up a thin wall structure. And this is all completely automatic. And in this example, we are 3D printing 7 layers. I do also want to showcase that it is possible to use the same path programming, which was shown in the previous module, simulation welding, in the same way, but in this case also 3D print. In this case here, we have imported a block with a kind of a snake movement. And then we can run this simulation here, you can see, with multiple layers with this path movement. In this case, we have also enabled the follow function or the kind of feeding function, so you can actually see the result of the 3D print in the simulation software. As you can see here, that is the red line which is moving. In this case here, we can 3D print with multiple layers and create very complex shapes. Also, in this case, we're using the rotary table with this path movement. We have in this video showcased how we can use the simulation software Visual Components to automatically 3D print a line, but also more complex shapes. We have also showcased that these programs can be directly transferred to the physical robot for welding and 3D printing. If you are interested in more tutorials on this module or other use cases, please follow the links in the description. Thank you for watching this Trinity module demonstration video.